Yeah! Oh, wait, of chemical equations.
Oh, well, still cool, though.
Yes!
Still cool. Dish, cool. Yeah.
All right, so a chemical equation is a simplified way of showing how a chemical reaction happens. And you see these words, reactants and products. We're going to go over those in a second. But, for example, if you were to say in words that 2 potassium atoms plus diatomic chlorine, meaning 2 chlorines, right?
Yeah, stuck together,
two,
it's
right?
2 chlorine.
That means 2.
Yep.
React to form 2 units of potassium chlorate. That's kind of, you know,
Wordy.
yeah.
Let's do it an easy way.
Another way of doing that is to write out a chemical equation just like this. You see 2K plus Cl2,
The little 2.
and then there's an arrow which indicates they form.
Yeah, there's a
thing.
reaction happening there. The
Right.
arrow means that these 2 things on the left side are reacting somehow and forming something new. Remember, something new is a chemical change, a chemical reaction.
Yeah, so
2KCl.
2KCl, yeah, potassium chlorate.
Another nice thing about the reason why we use all those symbols is it's universal. I mean, it doesn't matter. You could be speaking Swahili.
Yeah, they
and
still recognize
as
all the
well.
symbols on the
I should
periodic
preface
table.
as long as they know chemistry. I mean, obviously.
Yes.
Yeah.
Like some dude living in the bush might not know what it is, but
Yeah, so anyway. So now one thing that's important is to be able to pick out your reactants and products in all these chemical reactions. So whatever is on the left side of the reaction before the arrow, those are, I think it might be that way, wouldn't it?
put your hands up. Put your hands up. Palms out. The L is left.
Always the first stuff that you write down if you're writing from left to right.
Is so the atoms that are involved in the chemical reaction, they are the reactants. Good
Yeah,
way of
right.
remembering this is they're the ones that react.
Ooh,
Okay.
That's what you combine and they do a reaction.
Ooh, and RXN means what?
Reaction.
Yeah, that's-
RXN
Okay,
is
cool.
shorthand for
Love
reaction.
me some shorthand.
All right. So anyway, and products are the things that are actually made or formed.
They're produced.
For in the reaction. So this reaction is showing you have H2O and it is breaking up, and the products that are formed are hydrogen gas and oxygen gas.
So it's
Yep.
kind of like if you want to think of it, it's like the answer to the
Yeah, it is. It's the products. When you
Okay.
produce something, you make something. That's what's made out of a chemical reaction. You react something and you produce something.
Very easy.
All right. So someone else take
All
this
right.
while I'm talking too much.
So counting atoms is a very useful thing to do too, because one of the things we're going to talk about is that you can't like magically have atoms disappear or just come out of nowhere.
No.
There's this little law called the law of conservation of matter, which just says you can't create stuff out of boop, nowhere, and you also can't boosh get rid of it either.
Nope.
So what we talk about is the fact that on both sides you have to have the same number of everything. So it might be a good idea to be able to figure out what everything is. So we got a reactant side, we got a product side. Little arrow tells you it's a chemical reaction. And what we're going to do is go through how to actually count the atoms. So if you look at it, the question is how many hydrogen atoms are on the reactant side? Reactant side, again, is which side?
The left is what you start with.
Left. So we started. So how many H's are there?
well, there's a little 2 after the H.
There is.
And that means that goes with the letter before it, right? So that's
Yep.
got to be H2 means there's 2 H's. I'm going to say 2.
Yep, perfect. Now remember that 2, since it's touching the H, only goes with the H. Does it have anything
It
else?
doesn't go with the oxygen because it's in front of it, so it's not attached to
Right.
it, really.
Now the next question then is how many
Are on the product side.
on the product side?
How many hydrogens are on the product side? Looks like 2.
Yep.
Yep.
Another H2, and I don't see any other H's on that side.
Perfect. So that's good because 2 and 2. So we're happy there. Now, how many oxygens are on the reactant side? Remember, left side reactant, starting side.
There's 1 because we don't see a number there, so that means there's just 1.
Right. Remember, chemists, we like to be clean, and
Yeah.
putting all these extra ones and stuff in there just kind of looks weird.
No.
So we don't put them in there.
Well, it'd be like if you're doing an algebra problem and you write 1 before the X.
Right.
Yeah, it's
Exactly.
not
Just
1
see it as
X,
X.
it's just X.
X.
X means you have 1 of them.
Yep.
O means you have 1 oxygen.
Now, on the product side, how many oxygens are there? There's a little 2 there again.
There's
so
2. So there's
there's
not
2.
the same number of oxygens on one side than the other. So would that mean it's not balanced then?
It is not.
No.
It is not
We'll have
balanced.
to talk
so,
about balancing later, aren't
Well,
we?
yeah, we'll get into
Yeah.
that. So right now, it looks like it's violating that law of conservation of matter. It really isn't. We'll
It's
talk about how to
not.
fix it later.
We just haven't balanced it. We haven't put everything else in. But for now,
We'll get into that later.
That's counted up. So 2 H's on each side, 1 oxygen on the reactant side, 2 oxygens on the product side. It's not the
Yep.
same,
But we'll get to that later.
but it's counted.
Yep.
Yep.
All right.
So now we're going to look at maybe a bit more complicated of
Right. Because now we got
atom
this.
counting.
Now we got this 3 in the front. And this 3 in the front works very similar to how it does in your math class because it's a coefficient and it represents the number of molecules. So the little subscripts, the little small numbers like the O with the little 3 after it, those tell you how many of that particular item you have. The big numbers in the front of the molecule, they talk about everything that you got going there. So what that 3 means is you have 3 PbNO32s. It would be like writing PbNO32, PbNO32, PbNO32.
So give it a click and we'll see that. There you go. That's the number of molecules, and everything in that yellow box there is the molecule, which means it's PbNO3 2. That's one molecule. The number in front says there's 3 of that one molecule. So you got
Just
one.
refresh my memory. What does molecule mean?
Molecule is what? More than one atom chemically combined?
Yep. So when you have more than one, could be the
So
same.
look, we've got what, 3 elements there, don't we? We got a lead, which is the Pb. We got N and O, which I think are nitrogen and oxygen. So we've got 3 of them, and they're chemically combined. They're making one thing.
So you're saying then the molecule is multiple atoms put together.
Yes.
And in this case, the molecule is lead put together with all these N's and O's.
Yep.
Yes.
So you have that whole group, and then that 3 means that of that whole group, you actually have 3 of those groups together.
Imagine that PbNO32 was like a wooden block, and if I wanted, you'd actually have 3 of those wooden blocks right next to each other.
Okay, got it.
So when you go to count, it's really not that hard. It's just like in math class. The subscript, go ahead, is part of that polyatomic ion. So it's part of that little NO3, but it only is actually part of the oxygen too. So it's like tagged to it. So if I was just counting one molecule of PbNO32, what you'd have to do is that 2 on the outside is ultimately going to apply to everything. So at the moment, the 3 goes with the oxygen, but the 2 is going to apply to the oxygen and the nitrogen because it's on the outside of the parentheses. Just like in math, if you had 2 times x plus y, you'd do the 2 times the x and the y.
So let's go back one. I've got a question. On that NO3, basically what you're saying is we have a nitrogen atom, and then we've got 3 little oxygens sticking off, and that's what that little 3 says. It doesn't say 3 N's and 3 O's. It says just 3 O's, right?
Okay.
Like here's your nitrogen, and here's 3 little oxygens sticking off of that. And they're all still attached to that Pb atom, right? To that lead atom. Let's look at the next part then. You said that subscript outside of there
goes with everything inside the parentheses.
Oh, so then you say multiply everything inside the parentheses by 2.
Yes, so if there are, I'm going to use my mouse here, there are in this polyatomic ion, there are 3 oxygens and 1 nitrogen, that I multiply that by 2, meaning that there are 2 nitrogens
and 3 times 2 is 6 oxygens.
So what you do is you maybe write down on the side, okay, in each of these I got 1 nitrogen and 3 oxygens, but I multiply that by 2.
Yep.
Okay.
So we're counting these things up. It's basically just counting.
So let's actually put this all together. Now, how many lead atoms are there? Here's how I look at it. There's no subscript after that. It's not in parentheses, so I don't multiply it by yet another number. But the last number I look at is the coefficient. So I multiply that whole thing by 3. So there's no number here, so that means 1.
Yeah.
So and then there's no parentheses, so
just
nothing. So 1 times 3 is 3.
Cool.
Now the big number in the front goes with everything. That's the thing we got to remember.
So now it gets a little more complicated. This nitrogen, there's no subscript right next to it.
So that means it's 1.
1. But then I multiply it by the number outside the parentheses.
So
that means
times
so
2
far I
is
have
2.
2.
Okay.
So, and then after that I look at the number in front of the whole molecule. So 1 times 2 times 3 is 6. Okay.
Nice.
Now finally, the oxygen, we got the most math going on here. There are 3 oxygens in each polyatomic ion.
Okay.
And there are 2 of those polyatomic ions. So I go 3 times 2, that's 6. Then I take that number and I multiply it by the number in front of it.
There's 3 molecules, and each molecule has 6 oxygens in it. So it's 6, 12,
I'm going to need to take my shoes off. Hold on a second.
Right?
I can't count.
Yes, I get it. So we just have to remember how many molecules we have
18.
there, too.
Okay, 18.
Yep.
Okay.
So how many total atoms are present? When you add that all together,
That's some hard math.
I can't do that.
27.
It's in the upper 20s.
Woo!
27. Whoa, don't leave me hanging. And then
Now,
put it out. That's a
real
5.
quick, this might actually be an easier question than it looks
Yes.
like, but how many molecules are present? What's the number?
The number in front?
What's the number in
that
front?
big number? 3.
3,
So
yeah.
that says that we have 3 separate PbNO3 molecules, or NO3-2 molecules.
Right.
I get it.
Okay.
A bit.
That's not so bad.
What is the polyatomic ion that is present? How do I identify a polyatomic ion, do you think?
Well, in this case, it's easy because it's in parentheses.
Makes sense.
But what if we had like, can't you kind of look and say if you've got like two capital letters next to each other a lot of times, that's like two elements together?
Especially if they're two non-metals.
Two non-metals, yeah, like an N and an O, they're all the way over on the right-hand side near those noble gases, which means they're a non-metal. That's got to be a polyatomic ion, right?
Yeah, NO3. Yep.
Okay, cool. I'm getting it. It just takes a while to work with it.
Okay.
All right, so that's it for now. We're going to do a lot of practice with this in class.
Yeah, do it in class.
All right.
Done.
See you later.